Hello and welcome to Pre-Algebra Lesson 43. In this video, we're going to learn about dividing decimals. So our lesson objectives for today, we want to learn how to divide a decimal by a whole number, and also we want to learn how to divide a decimal or whole number by a decimal. So before I started talking about multiplying decimals, I told you that it was really no more difficult than multiplying whole numbers. You just have an extra step involved. Well, it's really the same thing here. Some cases you're going to have one extra step, in some cases you'll have two extra steps, just depending on what the situation is. But if you can divide whole numbers using long division, you can divide decimals. It's no more difficult. So let's start out by saying to divide a decimal by a whole number, which is the easier scenario, we just want to set up the long division normally and place the decimal point in the answer directly above the decimal point in the dividend. Now, I know we haven't talked about division in a while, so just remember, if you have something like 6 divided by 3 equals 2, the 6, the amount you start with, is the dividend. 3, the amount you're dividing by, is the divisor. And 2, the answer that you get, or the result, is the quotient. So once you've performed this step, where we place the decimal point in the answer directly above the decimal point in the dividend, you just divide normally. Right? You can just ignore the decimal point, pretend like it's not there, because you already know where it's going to be in your answer. All right, let's start out with 1.5 divided by 3. So we set up our long division normally. So I take my dividend, which is 1.5, and that goes underneath. I take my divisor, which is 3, and I put it off to the left. Now, the first step we're going to do is we're going to take this decimal point, and we're going to bring it straight up into the answer. Make sure it lines up properly, otherwise you won't get the right answer. Now, once I've done that, I know where the decimal point's going to be, and I can just pretend I have 15 divided by 3, right? So I would say, what is 3 going into 1? Well, we can't do that. So how many times would 3 go into 15? Well, that would go in 5 times. So I put a 5 here, and then I multiply. 5 times 3 is 15, and I subtract, and I get 0. So my answer for this is going to be 0.5, or I could put 0.5. Now remember, we can check division with multiplication. So we already know how to multiply with decimals. I could do 0.5 times 3, right? I could go backwards, and I should get 1.5. So what is 0.5 times 3? Well, we already know that we do 5 times 3. That would give us 15. And I would look to see how many decimal places I have between the factors. Well, this has 1 decimal place. This really doesn't have any. So I would move my decimal point 1 place to the left, and I would end up with 1.5, which is exactly what I started with as my dividend. Right? So we know that this answer is correct. 1.5 divided by 3 is 0.5. Let's take a look at the next one. We have negative 2.17 divided by 7. Now, again, if you're multiplying or dividing with negatives, the same rules that we learned with integers are going to apply. Negative divided by positive is negative. Once you find out the sign, you can just pretend like all the numbers are positive. You don't need to think about it anymore. So I'm just going to set up my long division as 2.17, and we're dividing by 7. Now, bring your decimal point straight up into the answer, and then you're done with it. You don't have to think about it anymore. You can just divide, like if you had 217 divided by 7. So 7 is not going to go into 2, but 7 will go into 21. It goes in exactly 3 times. 3 times 7 is 21. Subtract and get 0. Bring down the 7. 7 will go into 7 one time. 1 times 7 is 7. Subtract and get 0. So we have 0.31 as our answer. But remember, we have this negative up here. So let's attach that. And we'll say that we have negative 0.31 as our answer. And again, when you first start doing this, it's good for you to check, right? Take your quotient, your answer, multiply it by the divisor, you should get the dividend. So let's do one more where we check it. And then in the future, I'll leave it up to you to check your work. But it's good practice to check because you just learned how to multiply decimals. And so it can kind of reinforce what you learned. So you can take negative 0.31, and we're multiplying this by 7. So what is 7 times 31? So 31 times 7. 7 times 1 is 7. 7 times 3 is 21. So we would have 217 there. Remember, it's a negative times a positive, so that gives us a negative. And then we just need to figure out how many decimal places we have between the factors. We have 1, 2, right? None over here. So this would go 1, 2 places to the left. You'd have negative 2.17, which is exactly what you have here as your dividend. So again, you know your answer is correct, right? Our answer here is negative 0.31. Okay, for our next one, we have 44.95 divided by 31. So again, let's set this up. 44.95 divided by 31. Bring this up into the answer so you can forget about it. And now you just divide normally. So 31 will not go into 4, but it will go into 44. It'll go in once. 1 times 31 is 31. Subtract here and you would get 13, right? 4 minus 1 is 3. 4 minus 3 is 1. Now bring down the next number. How many times will 31 go into 139? Well, let's see. I know that 31 times 10 is 310. 310. Let's say I was to mentally cut that in half. Think about 310 as 300 plus 10. Cut 300 in half, you'd have 150. Cut 10 in half, you'd have 5. So half of this would be 155. That's too big. So my guess is going to be for 4. So what is 31 times 4? 4 times 1 is 4. 4 times 3 is 12. That's 124. So that's as close as we can get without going over. So we're going to put a 4 here, and we're going to multiply. 4 times 31 again is 124. Now we're going to subtract. 9 minus 4 is 5. 3 minus 2 is 1. So we'd have 15 there. And then we're going to bring down the 5. Now, we figured out earlier that 31 times 5 was 155, right? We just saw that. So I know that 31 will go into 155 5 times exactly. So this is going to be a 5. 5 times 31 again is 155. Subtracting, we get 0. So we get 1.45 as the answer. And let me just scroll back up here and write this next to this. So equals 1.45. So now we're going to kind of use this information to kind of tackle something that might have been confusing you for a while. I know that a lot of you will do division on a calculator. Let's say you have something like 17 divided by 5. So if you perform this operation using long division, 5 doesn't go into 1. 5 goes into 17 3 times. 3 times 5 is 15. You subtract and you get 2. So kind of up to this point, we've written 3 with a remainder of 2 as our answer. Now, your calculator won't give you 3 with a remainder of 2. It's going to tell you that the answer is 3.4. So how do we go from this format to the 3.4 format? Well, that's what we're going to get to right now. So let me erase this real quick and kind of give you the backstory. So I want you to recall that after a decimal point, a 0 does not add value unless it precedes a non-zero number. So something like 5.000000 is still 5. Right? Where you run into problems if you had something like 5.000001, well, these zeros do matter now, right? Because they come before a non-zero digit. They precede a non-zero number, okay? But if you don't have anything that's out there other than 0, you can put as many as you want. It doesn't matter. You're not adding value to the number. So knowing that, let's explore that 17 divided by 5 again and see if we can get 3.4 as our answer. So 17 divided by 5. So the first thing I'm going to do is I'm going to write 17 as 17 point, and I'm going to put 1 0 behind it. I'm going to put this decimal point up here in the answer, and now I'm going to divide like I normally would. 5 won't go into 1, so we say 5 goes into 17 3 times. 3 times 5 is 15. Subtract and get 2. Now instead of stopping and saying that's my remainder, I can bring down this 0. 5 goes into 24 times. 4 times 5 is 20. Subtract and get 0. So now you see what your calculator is doing. It's just continuing the division, right? So our answer here is 3.4. It doesn't make it wrong if you say you have 3 with a remainder of 2. It's just a little bit more precise to use this method and say, okay, well, our answer is 3.4. Let's try another one. So let's say we had 6.2 divided by 5. So 6.2 divided by 5. So we already have a decimal point here. Let's bring that up into the answer. And let's divide. 5 goes into 6 once. 1 times 5 is 5. Subtracting, you'll get 1. Bring down the 2. 5 goes into 12 twice. 2 times 5 is 10. Subtracting, get 2. So we're not going to say that we have 1.2 with a remainder of 2. we're going to continue the division. So remember, if I have 6.2, I can legally add as many zeros after that 2 as I want, not changing the value of the number. So let's continue our division. Let's put a 0 here, and then let's bring it down. So 5 will now go into 20 exactly 4 times. 4 times 5 is 20. Subtract and get 0. So our answer here is going to be 1.24. So we're going to get 1.24. And this is basically what we're going to do from here on out. We're going to continue the division until we get an answer, or sometimes we're going to get a digit that repeats or a pattern of digits that repeat. And we'll get to an example of that in a minute. All right, let's take a look at another one. We have 65.98 divided by 50. So 65.98 divided by 50. So bring your decimal point up into the answer. 50 is not going to go into 6, but it will go into 65. It'll go in once. 1 times 50 is 50. Subtract, 5 minus 0 is 5. 6 minus 5 is 1. And go ahead and bring down the 9. So now how many times will 50 go into 159? Well, 50 times 3 is 150. And that's about as good as we can do. So let's put a 3 here. 3 times 50, as I just said, is 150. Subtract 2, we get 9. Bring down the 8. Now let me scroll down and get a little room going here. So I know that 50 is going to go into 98 once. Only once. 1 times 50 is 50. Subtract, and we'd have 48, right? 8 minus 0 is 8. 9 minus 5 is 4. So we continue, right? We put a 0 after the 8, and we bring that down. So now we're going to ask, how many times will 50 go into 480? Well, I know 50 times 10 is 500, so I'd have to do 50 times 9. So 9 times 5 is 45. Attach a 0, it's 450. Let me kind of go back and forth here because we're not going to be able to fit all this on the screen. So 450, subtract, and you'd have 30. So I can keep adding zeros until I have something. So I'm going to add another 0 here and drag that down. I'm going to drag that down. So now I have 300. Now let me scroll up. So 50 goes into 300 exactly 6 times. So put a 6 here. And 6 times 50 again is 300. And when we subtract, we're going to have 0. So there's no remainder. So go up here. And our answer is going to be 1.3196. So let's take a look at this other scenario that you're going to run into. Occasionally, we're going to get a digit or series of digits that repeat forever. So when this occurs, we place kind of a bar over the part that repeats. So if I got an answer that was 4.33333, and that 3 just kept continuing forever, what I do is I just put a bar over the 3. Or if I had 3 digits like 367, 367, 367, I would just erase these and put a bar over the 3, 6, and 7, right? The part that repeats. Let's look at 1.3 divided by 6. So 1.3 divided by 6. So bring this up into the answer. 6 doesn't go into 1. It goes into 13 twice. 2 times 6 is 12. Subtract and get 1. Put a 0 here to continue the division. Bring that down. 6 is going to go into 10 once. 1 times 6 is 6. Subtract and get 4. Put a 0 to continue the division. Bring that down. 6 is going to go into 46 times. 6 times 6 is 36. Subtract and get 4. Put a 0 to continue the division. Bring that down. 6 goes into 46 times. 6 times 6 is 36. Subtract and get 4. Now, a lot of you at this point can already see there's an issue. Every time you continue this, if I put another 0 here and bring it down, I'm going to have 40 again. I had 40 here, then here, then here. It's just going to keep going because every time you're going to ask, how many times will 6 go into 40? Well, it's going to go in 6 times. So I'm going to have another 6 up there. I'll multiply. 6 times 6 is 36. I'm going to subtract 40 minus 36, and I'm going to get a 4. Bring down another 0. I'll have 40 again. This will continue forever and ever and ever. So once you recognize that there's a pattern going on, you just stop. And you say, okay, the 6 will repeat forever. So my answer is 0.216 with a bar on top of the 6. Okay, a bar on top of the 6. That way we know that that 6 continues forever. All right, let's take a look at another one where you'll have a pattern that continues forever. So you have 51.2, and we're dividing this by 11. So bring that up into the answer, and 11 will not go into 5. It's going to go into 51 4 times. 4 times 11 is 44. Subtract here. I would need to borrow. This would become 4. This would become 11. 11 minus 4 is 7. 4 minus 4 is 0. So I'll go ahead and bring down this 2 here. 11 will go into 72 6 times. 6 times 11 is 66. Subtract. I need to borrow. 12 minus 6 is 6. So I'm going to put a 0 here so I can continue. And I have 60. 11 goes into 60 5 times. 5 times 11 is 55. Subtract and I get 5. Go ahead and put a 0 here and bring that down. 11 goes into 54 times. 4 times 11 is 44. Subtract and you're going to get 6. So we're going to bring down another 0. And we're going to have 60. And remember, the divisor is 11. I don't want to scroll back and forth. The divisor is 11. So you'd say, how many times does 11 go into 60? Well, it's going to go in 5 times. It's going to go in 5 times. So this will be a 5. 5 times 11 is 55. 55. And subtract. You can already kind of see what pattern is going to emerge, right? You have 60 minus 55 here. And then you have it here again. So you know the result is going to be this next, right? Underneath it, I could basically just write 50 and 44 and minus and keep going, right? That's the pattern. But let me erase this real quick and say that, okay, this will be 5. This will be 10. 10 minus 5 is 5. And again, I'd bring down a 0 from all the way up top. Let me do that. And we'd have 50 again. 11 would go into 50 only 4 times. Only 4 times. So you can really see that it's 5, 4, 5, 4, 5, 4. That's the pattern that's going to continue forever. So 4 times 11 is 44. Subtracting, you get 6. So again, you're going to start out with 60 again, right? You have 60 here, and then you go to 50, then 60, then 50, and then that's exactly what's happening again. You'd have 60, you go through that again, you'd have 50, so on and so forth. It would just continue forever and ever and ever. So when you notice your pattern, you can go ahead and just stop and say, okay, I have 4.654. Now, the 5, 4 is what's repeating forever. So I'm going to put that bar over the 5 and the 4 only. But make sure you cover both digits, whatever's repeating. So I'm basically demonstrating that the 5 and the 4 will continue forever. So in other words, 4.654, 54, 54, 54, so on and so forth. All right, so now another important fact. Now, when we talked about multiplying decimals, I kind of worked into the situation when we multiply by 10 or a power of 10. And when I say a power of 10, I mean a whole number that is 1 or larger. So we're talking about 10 to the first power, 10 squared, 10 cubed, 10 to the fourth, so on and so forth. We saw that we'd move the decimal point one place to the right for every 0 in the power of 10. So if I did, 96 times 10 cubed, well, 10 cubed is a power of 10 with 3 zeros, right? It's 1,000. This is basically 96 times 1,000, right? So I have 1, 2, 3 zeros there. So I'm going to move the decimal point 3 places to the right. I'd go 1, 2, 3, and end up with 96,000 as an answer. When we divide by 10 or a power of 10, and when I say power of 10, again, I'm saying a whole number that's 1 or larger, we're going to kind of do the reverse. We're going to move the decimal point one place to the left for every 0 in the power of 10. So multiplying, it's going to the right. Dividing, it's going to the left. So if I have 96.12 divided by 10, the shortcut is just to say, okay, I have 1 0 going to the left by 1. That would be 9.612. If I have 96.12 divided by 100, the shortcut is to say, okay, I have 2 zeros, so I'm going to go 1, 2 places to the left, so I'd have 0.9612. If I have 96.12 divided by 10,000, I have 1, 2, 3, 4 zeros in this power of 10. So I'm going to have 96.12. I need to put 2 zeros over here. I'm going to go 1, 2, 3, 4 places to the left, and I'll end up with 0.009612 as my answer. Okay, let's talk about the other scenario now. So our other scenario involves dividing by a decimal. And basically what we're going to do here, we're going to move the decimal point in the divisor by enough places right to make it into a whole number. Now, once we've done that, our kind of next step is to match that movement with the decimal point in the dividend. So as a quick example, let's say I'm dividing 6.3 by, I don't know, 3.27. What I want to do is I want to start out with my divisor. Remember, that's the number you're dividing by. And I want to make it into a whole number. So I'm basically going to move this decimal point 2 places to the right. I just have to match that movement in my dividend. So for 6.3, I'm going to put a 0 behind the 3, and I'm going to move this 2 places to the right as well. So I'm basically turning this into the division problem, 630 divided by 327. Now you might stop for a minute and try to figure out how that's legal. The best way I can explain it to you is if you put it in fractional form, you can kind of think about having 6.3 in the numerator over 3.27 in the denominator. And let's say I just multiply the numerator and denominator by 100. Remember, that's just like multiplying by 1. So we would end up with, again, 630 over 327. So let's take a look at a few examples. So if I have 91.35 divided by 6.09, this is the divisor. This is the divisor. And essentially what I'm doing is I'm saying, okay, I need to move this 2 places to the right to make it a whole number, to make it the number 609. I just need to match that over here, move this 2 places to the right. Basically, I'm just multiplying each by 100, right? We learned earlier if you multiply by 10, you go 1 place to the right. If you multiply by 10 squared or 100, there's 2 zeros there, so you go 2 places to the right. And that's all we're doing. In fractional form, you can kind of think about this set up this way. If I just multiply the numerator and denominator here by 100, what I'm going to end up with is what? I'm going to end up with 9,135 over 609. Right? That's all I'm basically doing. I'm matching the movement that was made in the divisor that made it into a whole number in my dividend. Right? So that's the first thing we want to do. So once we have that, I'll just rewrite this problem. I'll just say it's 9,135 divided by 609. And we'll just crank that out real quick. So 609 will go over here. 9,135 will go here. Let me scroll down and get some room going. And so 609 will go into 913, right? It's not going to go into 9 or 91, but 913 once. 1 times 609 is 609. We would subtract here, and I'll borrow here. 13 minus 9 is 4. 0 minus 0 is 0. 9 minus 6 is 3. So that's 304. Bring down the 5. So we have 609. How many times is that going to go into 3,045? Well, you can eyeball this and see that it's going to work out perfectly, right? Think about 609 as 600 plus 9. If I multiply 600 times 5, I get 3,000. If I multiply 9 times 5, I get 45. So that tells me that what I'm looking for here is a 5. All right, 5 times 609 is going to give me 3,045. 5 times 9 is 45. 5 down, carry the 4. 5 times 0 is 0 plus 4 is 4. 5 times 6 is 30. So again, 3,045. So again, 5 times 609 is 3,045. Subtracting gets 0. So our answer here is just 15. So let me erase this and we'll scroll up and write that down. That our answer is going to be 15. Well, let's take a look at one more. All right, so we have 183.4272, and we're going to divide this by 21.23. So again, I'm looking at my divisor, and I want to make it into a whole number. So I need to move this 2 places to the right. Basically, I'm multiplying it by 100. I need to match that movement over here in the dividend. So I'm going to move this 2 places to the right. A lot of students get confused at first. They can't remember what they need to move. Remember, it's always the divisor, what you're dividing by, that you need to change it to a whole number. So I'm going to write this problem now as 18,342.72 divided by 2,123. So now let's crank this out. I have 18,342.72. Again, I'm dividing this by 2,123. And when you work with really big numbers like this, it can be very, very tedious. And I doubt you get something like this on a test. If you did, it would probably be like your final question or something like that. I just like to do some examples that are a little bit challenging so that you get experience working with something that's very tedious. So 2,123, it's not going to go into 1, it's not going to go into 18, it's not going to go into 183, it's not going to go into 1,834. The first thing we could check is 18,342. So we got to make some guesses. I would guess with a 9, that's probably going to be too big. So 2,123 times 9. 9 times 3 is 27. 9 times 2 is 18, plus 2 is 20. 9 times 1 is 9, plus 2 is 11. 9 times 2 is 18, plus 1 is 19. So that's 19,107. That's too big. So we're going to go with 8. So I'll put an 8 here. And let's do that multiplication real quick so we can get our product going. 8 times 3 is 24. 8 times 2 is 16, plus 2 is 18. 8 times 1 is 8, plus 1 is 9. 8 times 2 is 16. So I'm going to get 16,984 as my answer there. 16,984. We're going to subtract, and I'll need to borrow here. This will become 3, then 12. 12 minus 4 is 8. We'll borrow again. This will become 2. This is 13. 13 minus 8 is 5. We'll borrow again. This will become 7. This will become 12. 12 minus 9 is 3. 7 minus 6 is going to give me 1. And then 1 minus 1 is 0. So I get 1,358. 1,358. And I'm going to bring down my 7. So now I'm working with 13,587. So again, I'm going to make a little guess. So what I do is I think about, okay, 2,000 times 6 would give me 12,000. Let's just try that out first. So 2,123 times 6. Let me scroll down. Get a little room going. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 13. 6 times 1 is 6, plus 1 is 7. 6 times 2 is 12. So 12,738, that's as close as we're going to get. 12,738 is as close as we can get. So 2,123 will go into 13,587 6 times. 6 times 2,123, again, is 12,738. So now we want to subtract. And let me just move this over a little bit. So I'm going to borrow here to start. This will become 7. This will become 17. 17 minus 8 is 9. 7 minus 3 is 4. Borrow again. 15 minus 7 is 8. 2 minus 2 is 0. 1 minus 1 is 0. So basically I have 849. And I'm going to bring down this 2 here. So I get 8,492. So how many times will 2,123 go into 8,492? Well, I'm going to guess 4, right? Because 2,000 times 4 will be 8,000. So let's check that out. What would 2,123 times 4 give me? 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. 4 times 2 is 8. So 2,123 will go into 8,492 exactly 4 times. 4 times 2,123 is 8,492. Subtract, and we will get 0, and we are done. Our answer here is going to be 8.64. Let's go back up to the top and write that in. So this is going to be 8.64 as our final answer.